Okay, ready to work through another example of hypothesis testing using a t-test. In a certain city, a researcher wishes to determine whether the average age of its citizens is really 61.2 years, as the mayor claims. A sample of 22 residents has an average age of 59.8 years. The standard deviation of the sample is 1.5 years. At alpha equals 0.01, is the average age of the residents different from 61.2 years? Assume that the variable is approximately normally distributed. So the mayor is claiming that the average age of the citizens in this city is 61.2 years. So we can write that like this: mu, the average or mean for the ages of all the people in the city, equals 61.2. And because it's got an equal sign, it would be the null hypothesis. So the alternative to that would be that mu is different from 61.2 years. It's not 61.2. And so we would write that mu does not equal 61.2. That would be the alternative hypothesis. So it's got to be one or the other. Whatever that average age is, it's either 61.2 or it's not. Either the mayor is correct or the mayor is incorrect. Now for step 2. What are we using for mu? That's the number that we just wrote down in the null and alternative hypotheses. That was 61.2. What number are we putting in for x bar? That's the sample mean. That would be the average age of just the people in the sample. And it said here the sample of 22 residents has an average age of 59.8 years. So x bar would be 59.8. What is S? S stands for the sample standard deviation. Okay, see where it says the standard deviation of the sample is 1.5 years? So S is 1.5. And what about N? N stands for the sample size. That's how many people are in the sample. A sample of 22 residents, aha, there were 22 in the sample. N is 22. So we're going to put these numbers into the calculator or the spreadsheet or whatever we're using. Let me just bring up the spreadsheet on the t-test tab. Mu0 was 61.2. S was 1.5. X bar was 59.8. N was 22. And so the test value, T, is negative 4.377721, so about negative 4.38. And if H1 is mu does not equal 61.2, that's what it was, the p-value is 0.0002633. Just for fun, let's do it another way, like with the calculator. Now, when you're doing this, you only have to do it one way. I'm doing it more than one way, so you see how they all work. Then you can pick one that you like or that you can do, have what you need available, and do it that way. So if we did the graphing calculator method, push stat, go to tests, select t-test, make sure it's on stats, and put in 61.2, 59.8 for X bar, 1.5 for S, 22 for N. Select the alternative hypothesis with the does not equal and calculate. T is negative 4.377 something, and P is, it gave it in scientific notation, but it would be 0.00026 something. Okay, so T was negative 4.378. And P, the P value was 0.000263. And so if we use the table, all we can tell for sure is that it's less than 0.01, but that's good enough. Because when we come to step 4, we just need to know, is the p-value less than or greater than the level of significance alpha? Here, the p-value is less than that. It's a small p-value. The smaller the p-value, the less likely the null hypothesis is to be true. It's not really accurate to say that the p-value is the probability of the null hypothesis being true, but if you think in those terms, it can help you remember that a small p-value means the null hypothesis probably isn't true. A bigger p-value, then it's more likely that the null hypothesis could be true. But the p-value is kind of a measure of how far you could trust the null hypothesis. Here we can't trust it very much at all. We're going to reject it. So when the p-value that you get is less than the number you're using for alpha, you'd say reject the null hypothesis. And here, that was the mayor's claim. The mayor was claiming that mu equals 61.2. We just rejected that. So we're saying there is enough evidence to reject the mayor's claim. Or to put it another way, we're pretty sure that the average age of the residents is different from 61.2 years. Now, if we were having class in the classroom and we were together in person, I would give you a chance to try this out for yourself while we were together, and I could check and make sure you were doing things right or put you on the right track, give you some help, answer your questions. On the last page of the notes, there are a couple of more example problems labeled "Now you try." The first one kind of has blanks that you can fill in that lead you through all that you need to do, the steps you need to go through to do the hypothesis testing. And then there's another problem that I just give you the problem and then you can work through the steps yourself. I will post the answers to these on Canvas. I'll work these out and show you what the answers should look like, but you might want to try doing these yourself before you look at the answers I have posted to see if you got the hang of this. And of course, if you have any questions about any of this, ask me, send me a message or something like that. Try to help you out.